Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this session, we are going to discuss the very important topic in chemistry, atomic structure or atomic theory. Okay, let us start the session, guys. Yes, coming to the first one, atomic theory or atomic structure. Okay, in this first, we are going to discuss law of constant proportion. Law of constant proportion or law of definite proportions. What is this law of constant proportions or law of definite proportions? Law of constant proportions or law of definite proportion. It is a very simple concept, guys. Very simple concept. If you can consider any compound or so many compounds, in all the compounds, the elements are in the ratios. Okay, that is in constant proportions. That means, for example, if you can consider water, okay, what is the molecular mass of the water? Hydrogen H11, it has 2 atoms, means total mass is 2. Oxygen 8, 16. It has 1 atom, means total 16. 16 plus 2, 18. So 18 is the molecular mass of the water. So in this total 18, here we have that is nothing but in this total 18, 2 grams is said to be hydrogen and remaining 16 grams is said to be oxygen, correct? So 2 grams is said to be hydrogen, belongs to hydrogen, and remaining 16 grams is said to be oxygen. That means what is the proportion here? 2 ones, 2 eights. So always here, if you can consider any amount of water, here in that, hydrogen oxygen ratio is always 1 is to 8, is always 1 is to 8. Okay, that is nothing but law of constant proportions. So if you can consider a compound, in that the elements ratio or molecule, the masses ratio is always with a constant proportion. Okay, note on the point. Many compounds were composed of 2 or more elements. Okay, for example, if you can consider NaOH, here sodium, oxygen, hydrogen, 3 elements are there. Okay, C6H6 OH. So here also carbon, hydrogen, oxygen, 3 elements are there. So in the water we have 2 elements. So compounds were composed of 2 or more elements. If you can consider example, water H2O. Okay, this is composed with hydrogen and oxygen. Okay, and according to this law of constant proportion, according to law, in a chemical substance or chemical compound, in a chemical substance or compound, hence the elements hydrogen and oxygen, the elements are always present in definite or constant proportions. Definite or constant proportions by mass. Okay, just now we have discussed now the ratio is always 1:8. Okay, 1:8. So here if you, in case of the water, in case of water, the ratio of mass of hydrogen to the oxygen, hydrogen to the mass of oxygen, mass of oxygen is always, what is the percentage? 1:8 only. Okay, 1:8 only. So that means if you can take 18 grams of water, if you decompose this, then you will get 2 grams of hydrogen, 16 grams of oxygen. 16 grams of oxygen. If you take 9 grams, if you take 9 grams, in that 1 gram is hydrogen, remaining 8 grams is oxygen, like that. Okay, so this is nothing but law of constant proportions or law of definite proportions. Okay, now coming to the next very important, Dalton atomic theory. Dalton's atomic theory. If you have the question, who invented the atomic theory? That is nothing but Dalton. Okay, so you can give the answer. Who invented atomic theory? This is the most repeated question. That is nothing but John Dalton. John Dalton. Okay. According to this John Dalton, he said that the smallest particle is atom. He said the smallest particle is atom. Okay, and these atoms are invisible. These atoms are invisible. Okay, invisible. So note on that point. According to Dalton, the smallest particle of matter is atom. Smallest particle of matter is called as atom. Okay, and his theory is based on law of, his theory is based on law of chemical combination. Chemical combination. What is this law of chemical combination? It is nothing but mixture of two laws. That is law of chemical proportion. Just now we have discussed chemical proportion plus law of conservation of mass. Conservation of mass. Now mass. Okay, you know very well law of conservation of mass. Mass neither be created nor be destroyed. It transfers from one form to another form. Okay. So his theory is based on law of chemical combination, and according to him, so you can say the first and the second two important points he said. The first point is nothing but the smallest particle of the matter is atom. That is only the first point. All matter is made by very tiny particles called atoms. Okay, called atoms which participate in chemical reaction. Which participate in chemical reaction. Okay, and the second point is said that atoms are invisible. Atoms are invisible. Okay, and can't be created, can't be destroyed. And destroy. That is law of conservation of mass. Okay, and after this John Dalton, we will discuss the other two models. Okay, that is J.J. Thomson and Rutherford. After that, we will discuss Bohr's atomic model. Okay, and according to him, we have to know that the other particles, that is electron, proton, and a neutron. Okay, before that, atom and their size. And the third point, atom and their size. Okay, and atom and their size we denote in atomic radius. Atomic radius. This atomic radius is measured in nanometers. Measured in nanometer. Okay, measured in nanometer. Here 1 meter is equal to 10 power 9 nanometer. 1 meter is equal to 10 power 9 nanometer. That means 1 nanometer is equal to 10 power minus 9 meters. 10 power minus 9. Okay. Now, after this, coming to fundamental particles. Fundamental particles. Okay, so what are the fundamental particles we have? Electron, proton, and neutron. So are called as fundamental particles. Electron, proton, neutron. Okay, so coming to the first one, electron. Electron. We denote the electron like e power 0 minus 1. Okay, so that is minus is belongs to its a negative charge. Negative charge. Okay, these electrons are discovered in cathode ray experiment. Very important. Electrons discovered. Electrons are discovered in cathode ray experiment by the scientist is called as J.J. Thomson. By J.J. Thomson. Very important. Who discovered the electrons? Electrons are discovered by J.J. Thomson. J.J. Thomson. And these electrons are negatively charged. Very important point. Electrons are negatively charged. Okay. And the charge of electron. Charge of electron is equal to minus 1.602 into 10 power minus 19 coulombs. 10 power minus 19 coulombs. Okay, sometimes they will ask the question like one coulomb has how many electrons? 1 coulomb has how many electrons? How many electrons? Okay, sometimes they will ask the question like 1 coulomb has how many electrons? So what is the answer in this case? 1 coulomb is equivalent to 6.24 into 10 power 18 electrons. 10 power 18 electrons. Okay. So So reverse. 1 coulomb is equal to 1 by 1.602. Okay. Reverse. 1 coulomb is equal to 1 by 1.602 into 10 power minus 19. So minus 19 comes to the numerator, 10 power 19. Okay, so if you go with 1, 10 by 1.602 into 10 power 18. Okay, so 16, 6, 96 na, so 6.24 into 10 power 18 electrons. Very, very important, guys. One of the previous bit. Okay. And the next one, mass of electron. It is also very important. Mass of electron, that is 9.11 into 10 power minus 31 kg. 10 power minus 31 kg. So it is very less. The mass of electron is very less. So that's why it is considered as lightest among three particles. It is lightest particle among three. That is electron, proton and neutron. Okay, so the very important points here in the electron, all the points are very important. First one, who discovered the electron? J.J. Thomson. Charge of electron, that is negative. Okay, and what is the charge of electron? Minus 1.602 into 10 power minus 19 coulomb. That is the one important question. 1 coulomb has how many electrons? That is also important. And mass of the electron, that is also important. And in the following, which is the lightest particle? Electron, proton, neutron. Option D, all the above. Okay, in that case, electron is the answer. Okay, now coming to the next one, proton. Second particle, proton. Okay, proton. Here, the proton discovered by the scientist Goldstein, but he did not given any name. Okay, so the second case, Rutherford given the name for this particle, and that name is nothing but proton. That name is nothing but proton. So proton has two fathers. Okay, so here note down the point. Goldstein observed that positive charged particles observed that positive charged particles and called as canal rays, but did not give a name as proton. Did not give a name as proton. Okay, after that Rutherford verified it and named as proton. Okay, so if they are asking the question, who discovered the proton? Goldstein. Give the answer as Goldstein. Who named? Name given by, if they are asking name, given by, that is Rutherford. Okay, just wait, guys. Okay, name given by Rutherford. And these are protons. protons are positive charge. Protons have positive charge. Protons are positively charged. Okay, P for P. P for positive. And the charge of a proton is plus 1.602 into 10 power minus 19 coulomb. That means charge of electron and charge of a proton same, but only difference is sign. Okay, so we can note down. So magnitude of charge is same for proton and electron. Okay, only that is sign is different, magnitude is same. And coming to the mass of proton, mass of mass of proton is some higher than the electron, that is 1.67 into 10 power minus 27 kg. Here minus 27. Here if you can consider electron, that is minus 31. So minus 31 is the small now. So that is electron is the smallest. Proton is the somewhat of heaviest. Okay. Now the third one. What is the third one? Neutron. What is the third one? Neutron. Okay. These neutrons have no charge. As N for N, it has no charge and it is identified by Chadwick. Identified by the scientist called as Chadwick. Okay. So these are electrically neutral. As neutron has no charge. Has no charge. That means you can say electrically neutral. Okay, electrically neutral. And coming to the mass, mass is same as proton. Mass of neutron is same as proton, almost same as proton. So that mass of neutron is 1.67 into 10 power minus 27 kg only. Okay, it has no charge. It is identified by scientist Chadwick. You can say electrically neutral, and the mass of neutron is 1.67 into 10 power 27 kg. Okay. After this, coming to structure of atom, that is given by the scientist J.J. Thomson, Rutherford and Bohr's atomic model. Okay. So now coming to J.J. Thomson. Structure of atom. The first proposal by J.J. Thomson. J.J. Thomson model. He proposed the model that is called as Christmas pudding or watermelon concept. Christmas pudding or watermelon concept. That is very important for exam. Who discovered or who proposed Christmas pudding or watermelon concept? That is J.J. Thomson. Okay. He proposed the model of an atom. He proposed the model of an atom to be similar to Christmas pudding or watermelon. Okay, so if you can consider a watermelon, In this watermelon, the positive charge is spread like red edible part. Positive charge is spread like red edible part. Red edible part. Okay, so we have the red edible part of the watermelon is nothing but we can say positive charge. So positive charge spread like red edible part of the watermelon. And coming to electrons, just wait guys, where is my cursor? Here my cursor is not at all. Yes. Yes, 10 get electrons. So here electrons are spread like seeds of watermelon. So electrons are like seeds, that is negative, like seeds in watermelon. Okay, like seeds in watermelon. If you can consider Christmas tree, in the Christmas tree also positive charge is like a Christmas tree, that is the total leaves and all those, and some stars are placing now. Those stars are nothing but electrons. Okay, so here he proposed the model of an atom to be similar to Christmas pudding or watermelon. According to this, the positive charge in the atom is spread all over like red edible part, all over like the red edible part of watermelon, and while electrons are like seeds in watermelon. Seeds in watermelon. Okay. Seeds in watermelon. And he has given that the total positive charge is equal to negative charge in magnitude. In magnitude. So okay, he can say that the atoms are electrically stable, and said atoms electrically stable, but atoms are in real case not stable, so that's why this model is not um, continued, so it is discontinued. Okay, and the drawback of this J.J. Thomson model, it does not explain the alpha particle scattering. Okay, that alpha particle scattering is given by the scientist Rutherford. Okay, so note down the drawback is nothing but it could not explain alpha particle scattering. It is overcome by the scientist Rutherford model. Okay, so note down Rutherford model. And he is considered as father of nuclear physics. He is considered as the father of nuclear physics. Very, very important. Okay, and he conducted alpha particle scattering. Conducted alpha particle scattering experiment and proposed this model. Proposed this model or model of atom. what he said, according to him, the first point, any atom having its center or nucleus, okay, center of atom is called as nucleus. Center of atom, you can consider the total is the atom. Center of atom is considered as nucleus. This nucleus contains total mass. It contains total mass. Mass in the sense protons plus neutrons, and remaining electrons are revolve around the nucleus. Are revolve around the nucleus. Okay. Revolve around the nucleus. So note down that point. Note down the point here. Most can say electrons revolve around the nucleus in well-defined orbits. Well-defined orbits, and most of the atom is empty, and the most of atom is empty. Okay, and that means the size of nucleus at center at center there is center of atom is called nucleus. Okay, this nucleus contains nucleons. Nucleus contains nucleons, that is sum of protons plus neutrons. Okay, so that is total mass. Entire mass resides in nucleus only. Resides in nucleus only. The remaining, that is remaining particle is electrons. Electrons revolve around the nucleus in well-defined orbits. So if you can consider, it is one orbit, it is another orbit. So well-defined orbits. Okay. And the very important, he got Nobel Prize for this experiment. He got Nobel Prize, and also considered as, also is known as father of nuclear physics. Very important. Father of nuclear physics. Father of nuclear physics. And its drawback is nothing but drawback. He is also said the atoms are stable, but in real case the atoms are not at all stable. So that's why this Rutherford model also discarded, and after his Bohr's atomic model is proposed. Bohr's atomic model. Bohr's atomic model. Okay, this Bohr's atomic model is based on Planck's quantum theory. Based on Planck's quantum theory. So he proposed model of an atom based on Planck's quantum theory. Okay, note on this point. This theory is based on Planck's quantum theory. And according to Bohr's Here he is also said that at the center we have the nucleus, the center of atom we have the nucleus, and the electrons are revolve around the nucleus in a discrete orbits. Discrete orbit means n is equal to 1, 2, 3, 4, 5 like that. Okay, in a discrete orbit. So n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4 like that. And whenever atom is moving from one orbit to another orbit, here energy may be absorbed or energy may be released. Okay, that is given by this Bohr's atomic model. So note on the point, according to Bohr's atomic model, only certain spherical orbits, only certain spherical orbits, these are this round circle or spherical orbits known as discrete orbits. Discrete orbits. Okay, discrete orbits of the electrons inside the atom. Discrete orbit of electron are allowed inside the atom. Inside the atom. Okay, and the second point, while revolving in discrete orbits, that means in these orbits, discrete orbits, the electrons do not cross each other or do not radiate. Do not radiate energy. So whenever those are revolving around the nucleus in a discrete orbit, they may not radiate or emit the energy, but they are, whenever they are moving from 3 to 2, 2 to 1, in that case there is a chance of energy is emitted. Okay, energy, they do not radiate energy or loss energy, and he said that these orbits or shells are called energy levels, Okay, and the next point, energy is absorbed or emitted by an atom only when an electron moves from one level to another level. Okay, so energy is emitted or radiated whenever electron moves one level to another level. Okay, if it is just rotating or revolving in its particular orbit, there is no radiation or loss of energy takes place. Whenever it is moving from one level to another level, then only energy loss takes place. Okay, that is the only the point. That energy is equal to E2 minus E1, that is equal to hc by lambda. We know very well C by lambda is equal to frequency. You can denote with the nu or f. Then h nu or hf. Okay, nu is equal to f, that is nothing but frequency. You know very well units are hertz. This h is equal to Planck's constant, that is 6.62 into 10 power minus 34 joule second. Okay, units are also important. Units you can get E is equal to hf. Okay, if you want h, H is equal to E by F. 1 by F is equal to time. So E into T. So energy, joule, time, second. So joule second. Units are also very important. Units of Planck's constant, that is joule second. Joule second. Okay. And he said that if n is equal to 1, that is belongs to K shell, n is equal to 2, that is belongs to M shell, n is equal to 3 K L of that M. Okay, n is equal to 4 K L M N shell. Okay, given the shells like that. And he also given that the angular momentum is quantized, that is rounded off, okay, not in a point manner, and given that mvr is equal to nh by 2 pi, that n is equal to 1 2 3 like that. Okay, 1 2 3 like that, that is multiples of h by 2 pi, multiples of h by 2 pi. Okay, and its drawback is nothing but unable to explain Zeeman effect and Stark effect. Zeeman effect and Stark effect. Drawback is nothing but unable to explain the first one, spectrum of atoms other than hydrogen, and the second point, unable to explain Zeeman effect. What is this Zeeman effect? Magnetic field. So whenever a spectral line placed in magnetic field, it is splitted into number of lines, that is nothing but Zeeman effect. Okay, and unable to explain Stark effect. What is the Stark effect? In the same way, whenever you place a spectral line in the electric field, Stark electric field, it is split into number of lines. Whenever spectral lines placed in electric field, Stark shock, which makes the shock, that is electric field. It splitted into number of lines. So Bohr's unable to explain these two models. Okay. So here the very important point. Who invented the atomic theory? John Dalton. And electron. Very important. Electron. Here a small trick to remember. Who discovered the electron? Electron has one cap. In the J.J. Thomson also having more caps. J one cap, another J one cap, and Thomson T also one cap. So you can remember like that. So here P proton. Okay, P for positive. These are positive ions, and here it has two fathers discovered. Goldstein, name given by Rutherford. Okay, neutron and Christmas pudding or watermelon concept is proposed by J.J. Thomson. That is also important. Rutherford Model, who is the father of nuclear physics, Rutherford. Bohr's atomic model, unable to explain the two important effects, that is Zeeman effect and Stark effect, G-mod effect, ma for magnetic. So you can remember like ma for magnetic. Here electric Stark effect, Stark. Remember this Stark as shock. Okay, if you touch electric, you will get the shock. Correct? So like that you can remember Stark. Whenever you place spectral lines placed in electric field, it is split into number of lines. Okay. Okay, students, we will discuss the remaining in the next session. All of you, thank you so much for watching. And don't forget to click on like button. Okay.